Imagine for a moment that your future is not something that simply happens to you. Imagine instead that your brain is quietly predicting it every second. Before you walk into a meeting, before you try something new, before you even decide whether something is possible or impossible, your brain has already generated a model of what it expects to happen next. This prediction happens silently. Most of the time you are not even aware of it, yet it shapes how you feel, how you interpret situations, and ultimately, how you behave. For a long time, people assumed the brain's main job was thinking or reasoning. But modern neuroscience paints a very different picture. Increasingly, researchers describe the brain as a prediction engine. Its primary task is to anticipate what will happen next and prepare the body accordingly. Every moment your brain is generating forecasts about the world. It predicts whether something is safe or dangerous, predicts how others will respond to you. It predicts whether an action will succeed or fail. And these predictions don't just sit quietly in the background. They influence what you notice, what you ignore, and what actions feel natural or uncomfortable. If your brain predicts that a situation is threatening, your body prepares for stress. If it predicts success, your body prepares for engagement and exploration. In that sense, your experience of reality is never just about what is happening outside you. It is also about the model your brain has built to interpret what is happening. This idea might sound abstract, but it becomes clearer when we look at one of the most fascinating insights from modern neuroscience. The brain is constantly trying to reduce uncertainty. The neuroscientist Carl Friston describes this through what is known as the free energy principle. In simple terms, the brain works to minimize surprise. It prefers a world that behaves according to its expectations. Whenever reality deviates from those expectations, the brain experiences what researchers call prediction error. Prediction error forces the brain to update its internal model. But there is an interesting twist in this system. The brain does not always update its model quickly. Sometimes it resists change. Why would the brain resist updating its predictions? Because updating predictions requires energy. The brain is one of the most metabolically expensive organs in the body. Even though it represents only a small portion of your total body weight, it consumes a remarkable amount of energy. To conserve resources, the brain prefers familiar patterns. If a prediction has been reinforced many times in the past, the brain will keep using it, even if it is no longer perfectly accurate. This is why people often repeat the same patterns in life, not because they consciously choose them, but because their brains have learned to expect them. If someone has experienced repeated rejection, their brain may predict rejection in new situations. That prediction influences posture, tone of voice, and interpretation of social cues. Even neutral signals may be interpreted as negative. The person may unknowingly behave in ways that make rejection more likely. In this way, the brain's predictions quietly shape the trajectory of experience. Once you begin to see how powerful these predictions are, another question naturally arises. If the brain is constantly predicting the future based on the past, is it possible to change those predictions? This is where one of the most remarkable discoveries in neuroscience enters the story. For decades, scientists believed the brain's structure became largely fixed after early development. Once adulthood arrived, the neural architecture was thought to remain relatively stable. That assumption turned out to be wrong. Research over the past several decades has demonstrated that the brain retains an extraordinary capacity for change. This ability is known as neuroplasticity. Neuroplasticity refers to the brain's capacity to reorganize its connections. Neural pathways strengthen when they are used frequently and weaken when they are not. One of the foundational principles describing this process was proposed by psychologist Donald Hebb. Hebb's rule is often summarized with a simple phrase: neurons that fire together, wire together. When two neurons activate simultaneously again and again, the connection between them strengthens. Over time, these pathways become efficient routes for neural signals. This mechanism is how habits form. It is also how beliefs become stable. When certain patterns of thought and behavior repeat over time, the underlying neural circuits become increasingly strong. Eventually, they become the brain's default pathways. But the same mechanism that stabilizes habits also makes change possible. If new patterns of thought and behavior are repeated consistently, new circuits can form. At first, these new circuits are fragile. They require attention and effort, but with repetition, they strengthen. Gradually, the brain reorganizes its architecture. As that architecture shifts, the brain's predictions shift as well. And when predictions shift, behavior begins to change. Understanding this process reveals why many people feel trapped in familiar patterns, even when they want something different. The brain prefers efficiency. It prefers the pathways it has used before. Driving a familiar route is easier than navigating a new one. Thinking familiar thoughts is easier than building new perspectives. This tendency toward efficiency is useful most of the time. It allows us to perform everyday activities without exhausting cognitive resources, but it can also make change difficult. When you attempt something new, the brain encounters uncertainty. It lacks a stable prediction about what will happen. Uncertainty often feels uncomfortable. Sometimes it even triggers stress. Yet that discomfort is not a sign that change is impossible. In many cases, it is a sign that the brain is beginning to update its model. As new experiences accumulate, the brain gathers evidence. If the evidence consistently contradicts an old prediction, the model eventually shifts. This shift rarely happens all at once. Instead, it unfolds gradually. Small adjustments accumulate beneath the surface. New neural connections form. Old ones weaken. Then at some point a threshold is crossed, and behavior reorganizes. From the outside, these moments can appear sudden. Someone might struggle with a fear for years and then seemingly overcome it overnight. A long-standing habit might suddenly lose its grip. But beneath that moment lies a history of neural change. The brain had been quietly reorganizing its circuitry all along. This pattern resembles a phenomenon that physicists describe as a phase transition. When water is heated, its temperature gradually rises. Nothing dramatic appears to happen for a long time. Then a critical point is reached, and the water transforms into vapor. The transformation appears sudden, but the underlying process was continuous. In human experience, personal breakthroughs often follow a similar pattern. The brain accumulates small changes until the system reorganizes. Once the brain's predictions shift, the way a person interacts with the world changes. Instead of expecting failure, they begin to expect learning. Instead of anticipating rejection, they begin to anticipate curiosity. These subtle shifts influence behavior in countless ways. Posture changes. Tone of voice changes. Decisions change. Opportunities that once felt intimidating may now feel approachable. Conversations that once felt risky may now feel natural. The environment itself has not necessarily changed, but the person's interaction with it has. Over time, these behavioral shifts can produce dramatically different outcomes. This is one of the reasons people sometimes describe transformation as if they have created a new future. In reality, the process is less mystical and more biological. The brain updates its predictions. Those predictions influence behavior. Behavior changes how a person engages with the world, and that engagement shapes what becomes possible. Seen through this lens, the idea of creating a future takes on a different meaning. It is not about controlling the universe with thoughts. It is about reshaping the internal models that guide action. When those models change, the range of behaviors available to you expands. And when behavior changes, the probabilities of different outcomes shift. Attention plays a crucial role in this process. Where attention goes, neural activity follows. When you repeatedly focus on a skill, the brain strengthens circuits associated with that skill. When you focus on solving a problem, the brain begins reorganizing networks involved in reasoning and pattern recognition. Over time, sustained attention can reshape the architecture of neural networks. Emotion also plays an important role. Experiences accompanied by strong emotional signals tend to be encoded more deeply in memory. The brain interprets emotional intensity as a signal that something is important. As a result, emotionally meaningful experiences often leave lasting neural traces. This is why learning accompanied by curiosity, excitement, or personal relevance tends to be remembered more strongly. Emotion stabilizes neural change. Understanding these mechanisms reveals something profound. Your brain is constantly adapting to the experiences you repeat. Every habit, every pattern of thought, every repeated behavior gradually sculpts neural circuits. Those circuits influence the predictions your brain generates. And those predictions influence how you interpret the world. When people say that the future is shaped by what you do today, neuroscience offers a literal explanation. Your present experiences are continuously rewiring the brain that will interpret tomorrow. This process is not instant. It unfolds through repetition, attention, and experience. But it is happening constantly. Every time you learn something new, every time you practice a skill, every time you reconsider an old assumption, the brain adjusts. A small neural change occurs. A new connection strengthens. An old one weakens. Gradually, the architecture of the brain evolves. And as it evolves, your perception of possibility evolves with it. This is why people sometimes discover that challenges which once seemed impossible later feel manageable. The environment may be the same, but the brain encountering it is different. The neural circuits interpreting the situation have changed. The predictions guiding behavior have shifted. And because those predictions influence action, the outcomes that follow begin to change as well. Seen in this light, the idea of personal transformation becomes less mysterious. It becomes a story about biology. A story about how the brain continuously rewires itself in response to experience. A story about how predictions shape perception and behavior. And a story about how those predictions can gradually evolve. The brain you have today is not identical to the brain you had a year ago. It has been changing with every experience. Every conversation, every challenge, every moment of learning has left traces within its circuitry. Those traces influence how you interpret the world, but they do not lock you into a permanent identity, because the brain remains capable of change. Neuroplasticity ensures that the architecture of the mind is dynamic rather than fixed. And that dynamic architecture means the range of possible futures is always wider than it appears in any single moment. The most important shifts often begin quietly. A new skill practiced consistently. A new perspective considered repeatedly. A small habit sustained over time. Each of these experiences nudges neural circuits in new directions. And with enough repetition, the brain reorganizes. When that reorganization happens, what once felt impossible can begin to feel natural. Not because reality suddenly changed, but because the brain interpreting reality evolved. And that evolution may be one of the most powerful forces shaping the direction of a human life.